Hello learners, welcome to this lesson. I'm Teacher Agnes and today we are going to discuss how to measure the volume of irregularly shaped solids. So remember, we already dealt with solids that have a definite shape. Remember, like a sphere, a cuboid, a prism. So the volumes of such objects can be calculated. Now, what about objects that don't have a definite shape? They're just there like any, you can think of a random stone that you have picked from the side of the road. It may not have a definite shape. So if you wanted to determine its volume, then how would you do it? We have two methods of determining the volume of irregularly shaped solids. And the first method is by using a measuring cylinder. Now I need you to remember that this method is only applicable to solids that sink in water, solids that do not absorb water or dissolve in water. So how do we do it? So the first thing that you do is to partly fill a measuring cylinder with water. Don't fill it. Just get to a certain level, maybe half. And make sure that you record the volume of the water in that measuring cylinder. So number one, partly fill the measuring cylinder with water and then note the volume as V1. Step number two, take your solid, tie it with a piece of thread and then slowly dip it into the measuring cylinder, okay, until it is fully submerged. Number two, take your stone, tie it with a thread, and then slowly submerge it fully in the water. So not halfway, not quarter way, no, fully in the water. Now after submerging it, what do you expect to happen to the level of the water? The level of the water will definitely go up because the water will have created space for the stone to occupy and therefore it will go up. Space for the stone to occupy. So space means volume, okay? So after you have put the solid, determine the new reading. The reading is going to be different. It's going to be higher. So note the new reading as volume 2. So after that, how now do you determine the volume of the solid? Remember, the level of water has gone up just because there is a foreign object, which is a stone, inside the water. So the change in volume in the level of water is what represents the volume of the stone. So the volume of the stone will be given by volume 2 minus volume 1. Okay? So now let us discuss method 2. Now the second method that you can use to determine the volume of an irregularly shaped solid is by using a eureka can. Okay? A eureka can, or we can call that method the displacement method. Now for us to get an idea of what a eureka can is and even how this process goes on, we are going to start by watching a short video. So pay attention because we'll have a discussion after watching the video. Having watched the video and seen how this process goes on, I want us to make a summary. I want us to make a summary of the procedure that we use when using a Eureka can. So remember, the first step was to do what? The first step was to tie the object with a thread. So you can choose any object that does not have a definite shape. Number 2, we fill the Eureka can with water. Fill the Eureka can with water, and this is not the end until it does what? Until it overflows. So what is the purpose of this? So we need the water to overflow so that we are sure that we have filled the Eureka can to the brim. Okay? So any amount of water that overflows into the beaker, what do you do with it? You pour it, okay? Because we don't need that. So you empty the beaker. Empty the beaker. Then what do we do after that? Now our beaker is empty, ready to receive the water that will be displaced by our object. So number 4, we submerge the object fully, okay? Fully into the water. Fully in to the water, okay? Submerge the object fully into the water. Now, after you submerge the object fully into the water, some water will be displaced, because the object will need space to occupy. So water will be displaced to the beaker. But remember, a beaker is not the most accurate apparatus for measuring volume. So we will take the water inside the beaker and transfer it to a measuring cylinder. So step number 5 is to measure the displaced water. Measure the displaced water using a cylinder, okay? And the volume of the water displaced will be equivalent to the volume of the object. So the volume you obtain after measuring the volume of the displaced water will be equal to the volume of the object. So now we are going to do one question to test ourselves whether we have fully grasped this concept. So now let us attempt this question. So like you can see here, we have a diagram and we have a measuring cylinder, and then we have an object that is fully immersed in the water. So the initial level of water was at 10 centimeters cubed, but after putting the object inside the water, the level of water rose to 20 centimeters cubed. So what is now the volume of the stone? So remember what we have said, that we just need to get the change in the volume. So the initial level of water can act as our V1. So our V1 was 10 centimeters cubed, and then our V2 is 20 centimeters cubed. So the volume of the object will be equal to V2 minus V1. So our V2 is the second or the final volume, which is 20 minus V1, which is the initial volume, which is 10. So when you subtract the 2, you get 10 centimeters cubed. So the volume of the stone will be said to be 10 centimeters cubed. Now I'll give you one question that you will attempt to test yourself. Now you will attempt this question as your take-home assignment. The level of water in a measuring cylinder increases from 20 centimeters cubed to 25.6 centimeters cubed when a glass block is submerged in the water. Determine the volume of the glass block. I am confident that you'll be able to get this right. Thank you for being in this lesson. See you in the next lesson.